All right. So first time I read this, I read it wrong, and I went from P to R and 2 to 2 and R to P. I think what they're saying here is that each vector within itself makes an arithmetic sequence. So like P plus D equals 2, 2 plus D equals R, R plus D equals 2, 2 plus D equals P. So just kind of like looking at each of the components there. Okay, so we should be able to solve this system of equations here. If I subtract these two equations, I get P minus 2 equals 2 minus R. If I subtract these equations, I get R minus 2 equals 2 minus P, which is the same thing I got from before. You could rewrite that as P plus R equals 4. Great. I don't think there's much more that we can do there. So then the theta is the angle between the vectors, cosine theta. When you see cosine theta, you should think of that we have our formula for the dot product, that A dot B is equal to magnitude of A, magnitude of B, cosine of theta. And so cosine of theta then has to be equal to A dot B divided by magnitude A, magnitude B. And so in the terms of our vectors here, what do we have? Let's see, cosine of theta is going to be PR plus 4 plus RP, that's the dot product, over magnitude of A, square root of P squared plus 4 plus R squared. And then the magnitude of B is the same thing, and so we square it because they're multiplied by each other. Then, what do I know? Let's see. PR and RP are the same, so let's just simplify a little bit. We have 2RP plus 4, and then the square and the square root cancel. So P squared plus R squared plus 4. Okay. And we want to get everything in terms of D. I don't know that my earlier subtractions were extremely helpful. Let's see, because we don't really want to get it in terms of P and R. We want to get it in terms of D. So I'm going to get rid of this. Goodbye. Goodbye. So I guess what we'll do instead is rewrite everything in terms of D. So P equals 2 minus D. R equals um, D plus 2. Okay. And so then substituting that in down below, we have 2 times D. So sorry, 2 times R, so D plus 2 times P, 2 minus D plus the 4. And then on the bottom, P squared, 2 minus D squared plus R squared, D plus 2 squared plus 4. And then we just hope and pray that this comes out to be 6 minus D squared over 6 plus D squared. Okay, so what's up on the top? We have 2 times 2D minus 2D, and then we have plus 4 and D squared. So 2 times D squared minus 4 plus 4. On the bottom, we have 4 minus 4D plus D squared plus another D squared plus 4D plus 4 plus another 4. I'm going to move to the left. So on the top, we now have 2d squared minus 8 plus 4. And on the bottom, we have the negative 4d and the positive 4d cancel. So on the bottom, we got 4 makes 12 plus 2d squared. Oh, that's feeling pretty good. 12 plus 4d squared. And so let's see, I'm feeling like we should have had a negative involved somewhere on the top. Did I make a mistake at some point? Because I should have a negative d squared. I think, yep, my mistake here. So this right here should have been a positive 4, and this should have been a negative d squared, giving me with a positive 8 and a negative 2d. It's nice when it's a show that problem, because if you mess up your positives and negatives, you can usually just backtrack and fix it. And so one more time scooting to the left, I have 12 minus 2d squared over 12 plus 2d squared, which is the thing that was requested. Just divide everything by 2. Great. So now we want to find the common difference given that the vectors A and B form an angle of 60 degrees. We all remember that the cosine of 60 degrees is 1/2. And so now I'm just going to erase everything and say that 1/2 is equal to 6 minus d squared over 6 plus d squared. Cross multiplying gives me this wonderful equation, moving the d squareds to one side and the other things to the other side. No. 3d squared equals 6. Did I do that right? I think so. And that's a squared. And so d equals plus or minus the square root of 3. There we go. And was there anything else on this one? Looks like that's it. All right, great. One more down.